Well, hello, everyone. This is a special meeting for SIG cluster Lifecycle, and we are going to talk about add-ons. Just a reminder, this is a cluster Lifecycle is a CNCF project, so be kind with each other. And I pass over to Jack while I make Jonathan co-host.
Okay, thank you, Fabrizio. So we are gathered here together today to talk about add-ons in Cluster API, specifically a proposal that you, Fabrizio, initiated a few months back about leveraging Helm or something like Helm, basically leveraging a pre-existing packaging platform that has lots of community backing to do some of the work on behalf of CAPI add-ons reconciliation. So essentially, we have a proposal that outlines what that might look like, and that proposal is still in progress. So I welcome, if I have a browser tab open, like everyone else, I'm maintaining many browser tabs. But we'll provide a link in the chat and also in CAPI Slack to encourage folks to participate in that proposal. More concretely, Jonathan Tong and I have been working in parallel on a prototype of what this might look like. Jonathan's been doing that work in his own GitHub repo. Thank you, Fabrizio, for the link. And I kind of wanted to, the main purpose of this meeting is to get folks who are interested in add-ons in Cluster API, sort of make sure that everybody understands that there are some folks working on a prototype, maybe to sort of restart some momentum. I know this has been something that's been stop-started for many years now because it's a fairly complex surface area. It's a big chunk of functionality for something like Cluster API to take on. So I can imagine in past work streams, there being a certain amount of hesitance to sort of solve the world for add-ons within the Cluster API sort of scoped architecture. So anyway, I'm glad to see lots of folks here, and are both Jonathan and myself hosts? Looks like that's true. Okay, cool. So maybe to open it up, does anybody want to add any questions, ask any questions, or should we just kind of go through what we've got so far, and that will hopefully that will surface questions. Anyone have anything they want to bring up around just Cluster API add-ons in general? Okay. Jonathan, you want to?
If I may, I will add all two things. So one is that one of the goals of Cluster API is to leverage on the ecosystem. And this is what we're trying to do so to use what already exists in the ecosystem for orchestrating add-on. So we are not reinventing add-on management. We are just orchestrating something that already does add-on management in coordination with the cluster lifecycle managed by CAPI. This is why the proposal is called Cluster API add-on orchestration. And Helm is the tool that we are using. Second is that we are starting now. Probably we will be able to do much better soon, as we have lifecycle hooks that will basically allow, will provide a clean way to hook in the lifecycle of the add-on. So when I do install, when I do upgrade, etc., with the lifecycle of the cluster. But yeah, we are starting from the foundation, and that's only my remarks.
Great, that's definitely clarifying. Mike.
Yeah, so I guess I have kind of a general question, but I mean, I'm not trying to question the intents or anything here, but maybe while you're doing this, could you talk to, I think like, Helm is a perfectly good tool for, for kind of like templating manifests and stuff like that. But like, I'm kind of wondering from a user experience perspective, like, might it be easier just to allow a user just to put Kubernetes manifests in there and allow them to be consumed that way? And I wonder if you could talk to some of the challenges that maybe using Helm charts solves there. Because I just, everyone's used to manifests. Helm is like, well, many people are used to Helm, but I don't think Helm is like completely ubiquitous,
Yeah, I can answer or give a first try to. So, great question. So, first of all, Helm is not ubiquitous. This proposal is not the only solution. It is just demoing a solution using Helm. And so we are not excluding other tools in the ecosystems. We know that this space is super opinionated and people like the flavor of Addon management. Okay, what problem we are? So what capabilities we would like to reuse? So first of all, tools like Helms have already solved a lot of problems that are related to Addon management. I make you an example. Packaging. How do you distribute your Addon? Okay. Another one, templating. How you allow some variables, some information about the cluster to flow in your Addon. Management. Once your Addon are in the cluster, how do you allow discovery? Helm list gives you the list that are of the Addon that are into the cluster. And so, last but not least, at the end, Addon are a Kubernetes application. So what we expect is that people that opt in Helms or Argo CD or different tooling, they want their Addon and their application managed in a consistent way, because they basically leverage on a single tool chain. So that's the advantage. We reuse some capability, packaging, templating, eventually reconciliation of the installed stuff, etc., and we basically met the customer where they are instead of proposing something different. This is the main advantage in looking to reuse what the community has instead of reinventing the wheel.
Kevin. Or Mike, do you want to respond?
No, I was just going to say thanks for expanding on that. I think, this is one of the things where it's like, you're absolutely right, Fabrizio, that, yeah, this is a very opinionated space. That's why I was trying to go back to the baseline, just our manifests. And of course, that doesn't solve the problem of injecting variables that might exist in the cluster into something you might want. But I wanted to kind of expose some of those details, because I think, there's kind of the simplest layer that everyone understands, and then everything else is something you have to learn to kind of get into these things. So thank you for expanding on that.
To be honest, as we walk through some of this stuff that Jonathan and I have prototyped, folks will probably notice it wouldn't actually be hard to do the exact same thing with raw YAML, although that's probably going to be out of scope, and Fabrizio maybe doesn't want me to say that, so we don't get folks' hopes up. But it would actually be really easy with reduced functionality to just use YAML and have the ability to define affinity between CAPI clusters and this new CRD, and then just kind of like cluster resource set. Kevin.
Yeah, so this is definitely a very opinionated space. What I'm wondering is, can it be more narrowly focused in the problem space so it doesn't step on other things so much? Like for example, starting up a kubeadm cluster, you have the base Kubernetes, and then it does a couple of add-ons in the realm of kubeproxy and core DNS. And they're really kind of needed by the core cluster to function properly, and other things kind of expect them to be there, but they're kind of add-ons also, right? And maybe the networking layer is kind of at an add-on layer too. And more, the things like OLM, like expect core DNS to be there and working in kube proxy and an SDN layer, or Argo, or all the other like ways of doing package management or managing the things, kind of expect that base layer cluster. And so we've got the really low level stuff. We've got that little bit of add-on in between that's much more variable than that really base cluster. And then we've got like everything else built on top of it. And I'm wondering if we can scope the add-ons for discussion here in such a way that it's really just that middle piece that's maybe less religious, and there might be more common ground that can be found there.
I can formulate a response. Fabrizio, would you like to say a response first?
No, please go on.
So I would actually advocate that one of the things that we agree to, or this is my idea, is that we don't define what an add-on is as part of this work stream. And so we simply define a set of functionality that we fulfill, and that if you can use that set of functionality to do something on your cluster in an add-on like way, then that thing that you're doing qualifies as an add-on, but we don't worry about sort of fulfilling first principle definitions of what an add-on is. So is core DNS an add-on? Is Calico an add-on? Is Outage Cloud Provider an add-on? I agree with you, Kevin, that there is no easy way to define where the frontier begins and ends there.
I'm afraid if you don't define it, then it becomes a religious argument and people push back against it, not understanding what's trying to be solved and why they don't conflict.
Yeah, that's a fair point. In the document, we try to provide, and we already iterated 2 or 3 times on what is the definition of a cluster add-on. So in TLDR, it doesn't really make sense to use what we are demoing today only for add-ons that are really related to the cluster lifecycle. Add-ons that you need to install when you create the cluster, add-ons that you need to update when you update the cluster, like CPI, CSI. In my opinion, other add-ons does not really make sense. This is what we are trying to, let me say, this is the scope that we are trying to limit. Add-ons or Kubernetes application, because at the end they are Kubernetes application, which you need for your cluster to work, and which life cycle is linked to the cluster. But really, if you have better idea and you can help us in shaping out the definition, I agree with you. This is an important part of this proposal, making people understand what the problem we are solving.
Yeah, I think you run the danger of like, well, why do I need the OLM then? I can just make my operator deploy with the add-on tool, and then like some of the best practices around being able to scope an operator to a namespace aren't easily possible with that tool, but people don't know that until they dig through the details enough, and there's just a lot of confusion that can happen when things aren't scoped well up front, I think.
Yeah, I agree with that. I do think that a lot of this can be clarified by strongly stating that this proposal is not being put forward in order to better solve problems that have existing solutions. So you lay out things like core DNS, like those, there are solutions for that Cluster API could not really exist if kubeadm, it couldn't exist in its current way if kubeadm wasn't handling those things. So those are solved problems. Like Cluster API doesn't have the problem of how do we get core DNS on my cluster?
It kind of does. I was talking with some of the kubeadm folks, and they're waffling on, do they want to cut core DNS loose? For these kind of reasons, right? What does an add-on mean? Is core DNS really an add-on? They're having the same problem defining what an add-on is.
Right. And I see that Mr. CubeADM has his hand raised. Go ahead, Lumir.
Ah, very nice qualification you gave me there. But anyway, I wanted to point out that I think we want to cut coordinates out, not because it's like an add-on or not an add-on. It's actually, it's a problem for us to maintain it because of the migration library that it has to import. We import this migration library also in cluster API. And if you look at Helm, for example, Helm cannot solve this problem because I don't think Helm executes any Go code when you upgrade an add-on or something that deployed on Helm. So it's like you have to have an operator for core DNS. But if both cluster API and CubeADM need this add-on, maybe it should be like a separate entity, like a separate application that both of them can deploy. And maybe CubeADM can skip it, cluster API users can deploy it and customize it in the way that they want. But we cannot do that today. And actually, the cluster API users of CubeADM have to skip the built-in add-on. And maybe they can use a Helm or something else to deploy it on their own. But the space is really, really entangled. And going back to the topic of whether an add-on is a Kubernetes application, I think that if you design this solution, it's like a workable at some point. People start using it. Maybe they can actually use the hooks to treat their cluster applications as add-ons. So basically, they might want to upgrade their applications with the same hooks that you use for the add-ons proposed in this solution. So I'm generally in favor of this. I still, of course, about the overall ecosystem, I have concerns that we are designing a solution for something high in the stack, like a cluster API. And lower in the stack, we have we are not going to have this add-on manager that is workable for CubeADM users. But I see the demand, and I appreciate that there are efforts on the cluster API level. So that's what I wanted to say about this. But yeah, if you have any questions, something, I will happy to respond further.
Well, I definitely do think it's worth clarifying that we are working at those cluster API higher levels of the stack, like explicitly. There should be no illusions about, we're not trying to solve add-ons for Kubernetes. This is really a cluster API solution. And one thing we haven't mentioned thus far is one possible problem area that this is going to solve is for common componentry that exists across a fleet of clusters. So it doesn't have to be, I think we've been focused on how core a thing is in terms of its add-onness, but it doesn't have to be like a core part of the cluster functionality. It could just be a very domain-specific set of complementary componentry that I, managing my hundreds of clusters, install on, I install the same componentry in common across all those clusters. So having a cluster API aware solution where I can define that one place, and then cluster API will take care of rendering that across all the clusters that have those.
That may push the packaging requirements back to the developers who now need multiple packaging mechanisms to concern themselves with, right? Like some folks their preferred way of packaging things might be like the OLM, say, but they might need to package it also as an add-on in order to reach some other subset of folks. It's kind of unavoidable, I think, for kind of that bootstrap-y low-level component place that it's maybe unavoidable. But at the higher level, the ability to take an app from Kubernetes cluster to Kubernetes cluster and deploy it, commonly without changes across all the clusters, that's one of Kubernetes' really strong points. We have to be careful not to step on that, I think.
Arun?
I just mentioned it in the chat, we are close to the halfway mark. And I think add-ons is a good topic. And as Kevin has mentioned, it is going to be a religious topic with a lot of discussion. So should we schedule separate time for that and go on with the actual Helm demo? And I think many of us are looking forward to how it would work. And of course, this is a fundamental question, but I do not want this to become a bike shedding sort of a discussion with everybody adding their idea about what an add-on should be like. And I understand that
You've come to the wrong community, Arun. No, just joking.
We should have a separate discussion for that, not to downplay that, but I just want to see what is available now and come to that discussion separately and add my opinions as well.
I'm totally fine with that, unless there's significant opposition. So Jonathan, I think you are co-host.
Yep.
Do you want to? So this is Jonathan Tong, and I work on CapZ together, and he has been prototyping what this might look like.
Yeah.
I'll hand the floor over to you, Jonathan.
Yeah, give me a sec to share. Cool. So I guess we've been prototyping a controller using Cube Builder as a way to build up proof of concept and also to experiment with some features that could inform how we decide to finish up the proposal. So to test out our controller, we made a sample of the CRD called Helm chart proxy. And in there, we have a label selector that selects.
So you're sharing a browser with Tilt. Is that what you intend to share?
Oh, my bad. That's the wrong window. Are you seeing the whole screen or just the window? It's not showing me which
so
one.
I see your VS Code.
Okay,
right
can
now.
you see my terminal now? Or just VS Code?
Just VS Code.
Okay, that's a little weird.
You can share only a Windows at a time with the Raster Lifecycle Zoom. I don't know why. You cannot share the desktop.
Oh, okay. I'll just switch the window if we need. But yeah, so this is an example of the CRD we've defined. We have a selector that lets you select the workload clusters we want to install it on. So here we try to match labels with cloud provider Azure True. And for the Helm chart, we specify the repo URL, the chart name, and the release name we want to install, as well as the version. So this is enough for Helm to figure out where the chart is. And once we have the chart, we've been experimenting with this values field. So this is a list of string maps. And this allows us to pass through the -- set field in Helm where we have a key and a value. So we can set cloud controller manager container resource management limit CPU to 6. And this another thing we've been experimenting with is, say we want to have the cluster name for each workload cluster to be resolved at runtime. So we've been experimenting with adding this sort of syntax where anything in these double braces, we can specify the cluster resource and access the fields in there. So far our controller imports Helm as a library, and we just use a reconciler to watch for Helm chart proxies. And when we get it, we select the clusters, and then we can go ahead and apply that. So
since we can only share one window at a time, any questions before we move over to console sharing? Any questions on the code itself or the CRD spec? Cool.
Yeah, I guess just to add on a bit more, this is sort of the first iteration of the proof of concept / prototype. And here our goal was to install Helm as a library and be able to install the Helm chart, upgrade it when we see a change, and delete it. And so far, we've imported Helm as a library. Even though there isn't an SDK, it seems pretty straightforward so far to implement. And with that, we can go ahead and switch to console. So here we can go ahead and apply that spec. And we can see that we have in the logs that we have installed the release. So if we look in our cluster default, we have this label in the Helm chart proxy that we're matching here. And so when we go into this cluster, I've already set the cube config ahead of the time. We can see that the Helm chart is there. So we could go back and make some changes.
So to be clear, the CRD that kapply was being installed against the management cluster. So you want to, can you just cat that real quick? Imagine that you're an operator before you apply it again.
Yeah, 1 second. There's the zoom. Do you know how to get rid of the zoom thing? All right, I got it. So we can cat the yeah, there it is.
Cool. So yeah, this is an example of a implementation of the CRD Helm chart proxy that we would be installing on our management cluster. And then this would target all clusters running on the management cluster that had the cluster label, the Cloud Provider Azure True label, I think in the cluster spec itself, in the cluster resource. Is that right, Jonathan?
Yeah, in the cluster itself.
So maybe can you quickly just show, do like a kget clusters, and we can like describe the cluster resource.
It's up here.
Okay, cool. There you go.
So yeah, here's the label.
So that defines the affinity between the cluster and the CRD.
Yeah, that's sort of the same behavior we have in cluster resource set so far. And it's pretty straightforward to bring over, though we could probably make some changes to that if we need.
So yeah, Kevin, you asked a question in chat. Great question. That's really important to understand, is that I think, at least in terms of the scope we're working under, that is the defined scope, is that we're solving the problem for installing add-on componentry on workload clusters, not on the management clusters themselves. Do you want to add any more questions or express concerns or anything?
But managed from the management cluster. So the source of truth for those add-ons is on the management cluster.
Correct.
Yes.
Like the source of truth for all things in cluster API is we're talking about cluster API specifically, not the workload Kubernetes clusters. Go ahead, Fabrizio.
So this looks great. So I have some question about the version of the add-on. So if I remember well, in the CRD, we are defining a version of the add-on. Is there a relation, and what is this add-on, a CPI, CNI?
This is Cloud Provider Azure. This is
okay.
So that's the version of the chart. That's the version of the chart.
Okay, and how it is decided which version of the CPI to install according to the version of the Kubernetes cluster? Because CPI, there is a relation between Kubernetes version and add-on version.
That is such a good question. That is going to be dependent on each individual chart. For this chart, I can speak to because I actually maintain this chart in the Cloud Provider Azure repo. This chart does that automatically. So Helm provides a primitive called, it's like capabilities.kubeversion or something or other. So for charts that deliver things that are sensitive to the version of Kubernetes that are actually running, you can actually templatize that in the chart itself. So the way that that works for cloud provider is that the out-of-tree cloud provider for Azure maintains separate releases that map to specific Kubernetes releases. So if you're on 123, you need to use the version whatever of the cloud provider Azure runtime. And so in that chart itself, there is logic that will reference the correct cloud controller manager and cloud node manager image, depending on the version of Kubernetes that it's detected at runtime when you install the chart. So there are other ways that this could also be expressed depending on the chart. But because Helm provides that primitive capability, it would make the most sense in as far as this CRD, assuming that we're using Helm, to leverage that as opposed to adding additional introspection functionality into the controller itself running on the cluster API, because we get that for free in Helm. If that makes sense.
Yeah, this makes sense. It is just I think that is important to point out in the document, because it is kind of elegant, and but yeah, it is a requirement for the Helm chart authors. So follow-up question. I don't know, probably it is not yet there in the POC, which is, by the way, a great work to get started. What happened when my Kubernetes cluster gets upgraded?
You want to take that one, Jonathan?
That's something we're planning on getting to soon, actually. But actually, going back to what you were saying before, I know you mentioned in the document, we're talking about adding a compatibility matrix to match the chart version and the Kubernetes version. So Jack, are you saying that what Helm does solves that problem for us, or do we have to implement that when like the chart doesn't provide it on its own, if I'm understanding this correctly?
So Helm provides a solution, but it's up to the chart author to actually leverage that. And as folks have suggested in this call, you know, there's like a million different ways that people are using package managers, including Helm. So we can't take it for granted that that'll be the case. That being said, I think it's appropriate for an MVP type thing that we're working on here to call that out of scope. And we can, I think based on maybe further discovery in the ecosystem, we can discover how practical it would be to ship something like this, and essentially say, if you need to deliver your add-on in a way that's specific to certain versions of Kubernetes, then you must, this is how you do it in the Helm chart authoring way.
Yeah.
Arun, do you want to say something?
It's a sort of a separate question, not a follow-up. Sorry.
But yeah, does that answer your question about upgrade, Fabrizio? Essentially, we haven't done it yet. The way that I think it would work is we would just do a subsequent Helm install, and Helm is smart enough, in assuming that you have sensitivity defined in the Helm chart to Kubernetes version, Helm is smart enough that it would re-render the actual complete set of Kubernetes specs, and there would be a diff there compared to the existing, because following the upgrade, you would have a new version of Kubernetes. Or if it wasn't, let's say the only difference is between 121 and 122, but 122, 123, 124 all get the same, then the Helm install would essentially do nothing. But that's actually work that Jonathan had to do ourselves, because Helm doesn't do that. It's not that smart, actually.
That's fine. I know this is in Python. I think that this is important. So the idea is that with this prototype, and this is where orchestration kicks in, and we are, let me say, becoming really different than cluster source set, is that with this POC, we are not only installing, but also orchestrating. And orchestrating is synced with the Kubernetes. So this is, I wanted just to highlight this, because I think that this answer to, this helped to understand the idea, but great work, Jonathan. Really looking forward for the next step.
Yeah, so we can demo that
Thanks.
in a few minutes. Like we can delete the CRD and we can see that orchestration in action.
Yeah.
But let's quickly get to chat. So Arun, you asked, can you list pods on the management and workload and talk about any prerequisites needed? Can you expand more on that?
So I was just curious, you could do a Helm list of things which were installed by the CRD. So how did Helm understand that by actually, I have not used Helm that much. So at one point Helm used an operator, but nowadays we don't use those operators and Helm works directly, I suppose. So how did Helm understand that this cluster, the operator actually installed it? So how did Helm actually show that when you did a Helm list?
Well,
So,
I think we probably need a Helm expert on here, but I think what Helm does at runtime is it takes the set of results from the various Kubernetes resources that it installs, and it bubbles that up as a like terminal state. So it would fail if any one of those resources failed to install, and then it keeps all that data somewhere, in etcd, whether it's a config map or something. I'm not exactly sure how it works under the hood.
So the other thing was, so just because since Helm sees that, then somebody can do a Helm uninstall of Cloud Pro Azure, right? And would the operator kick in and reconcile and actually install it again?
Jonathan, I think that's unimplemented, but I think that would be the idea. That would certainly follow the cluster API pattern. So we would be very
Yeah, that's not something
non-idiomatic.
we've gotten to yet, but that's definitely something we want to do.
Yeah, I would imagine that's just how cluster API works. So we would want to do that. So long as the CRD is defined and the cluster labels are intact, then we want that eventual consistency to be guaranteed, including in situations when some out of band deletion happened. Go ahead.
Right. And one last question. This is regarding Fabrizio's itself. For things like, for example, kube proxy and so on, there is a sort of complex orchestration wherein when you have a rolling upgrade, you have a newer version coming in and the older version deployment still needs to be there. So there is a sort of a handoff wherein the whole thing comes up and then it's killed in the new cluster has the old version and then that is deleted and a new thing comes up. So Helm is at a top level, right? I don't think it is built to actually see two Kubernetes versions. Is it built with that? Intent. I'm not sure if I'm explaining the problem correctly. So for example, your cloud.
It's just loading templates into the cluster. You could potentially build a kube proxy chart that had two daemon sets in it with different versions pinned to different types of nodes, but it couldn't really help orchestrate that process of rolling through things.
So it is Helm assumes that it's going to have one static Kubernetes cluster.
Helm is going to rely upon the leader-elect winner of the control plane to report the version of Kubernetes running on the cluster, which is not going to always be the same, especially during upgrade situations, as every single node running in that cluster. Mm-hmm. So as far as I understand it, Helm will take what the control plane returns back as the version of the cluster.
So it can't necessarily be a one-time thing. It might need to be reconciled several times before it notices the cluster is enough the new version that it does the new thing.
Well, I think the important point would be that if the upgrade orchestration is following the Kubernetes recommendations where the control plane is first and the nodes are second, assuming some sort of serial order of operations, that the control plane is going to transition to its new version only one time. And as the nodes are upgraded, if, for example, let's say Helm does an upgrade based on a cluster transition, and one of the underlying pods gets scheduled on a node that's then upgraded an hour later, assuming that we're not dealing with a static pod here, that pod would obviously get cordoned and drained in a graceful upgrade situation when it gets scheduled onto another node. Eventually, the Towers of Hanoi thing would reconcile where the cluster be fully upgraded and all the right upgraded bits of Helm are running as pods on the upgraded nodes.
Thanks.
Scott is ready. Fabrizio, do you want to talk to this?
Yeah, let me. Sorry, Scott. I just answer to these questions. So I think that we don't have a solution, but we are laying out the foundation. So if you think at today, what we have today is the kubeproxy manifest, which is hard-coded in kubermin. And with that, you cannot do really much. Okay. Now, what we are giving is you can write your own manifest, and we are giving you this Addon orchestration that will hook into the cluster events. And so these provide the foundation for orchestrating, create first Addon, the latest first daemon set, the latest second one, etc., etc., etc. So we are starting from the foundation, but we're giving you the tool to get there.
Scott.
Yeah, I was just wondering if the idea had come up. I know you're using match labels right now for the clusters, but if match fields or match expressions was used here, even though they're less friendly syntaxes, it could be used then per version. And then could, just by adding the match fields in there, it could match off the field of the specific Kubernetes cluster, of the workload cluster, which could make it so that we can support more types of Helm charts than ones that necessarily use capabilities cube version. Because you could just have Helm chart proxies that are relevant to each cluster, and a new one would be installed. The new cloud provider would be installed basically in the cluster when you go through an upgrade. And that could support more use cases.
I like this. I like this exercise where we're imagining this is a real project and we're setting out our next release milestone. Good call out. Guillermo?
Yeah, I have a question. When you mentioned that Helm already has the capabilities to map internally different versions of the charts of different releases to different versions of Kubernetes, which in my mind, it was one of the first goals of this kind of project, to have the ability to do those things, whether it's with Helm or any other tool. And that made me think, well, it's kind of like a fair solution to say, hey, Helm already supports this. We don't need to implement it at the proxy level. Helm can already do that, right? And then, as you said, we can talk in the future if most of the charts don't support this functionality. Hence, we should probably implement it at the proxy level. But if we are leaving it up to the add-on orchestrator or add-on provider, however we call it, to solve those kind of problems, what are we defining at the framework level, right? So I see this Helm as like one implementation of this framework. What is the minimum set of requirements that, or the minimum set of patterns that this framework is adding? Because as of now, the only thing that I'm seeing is we're going to have a controller that either uses the hooks or watches objects in the cluster, and based on that, performs some kind of operation based on some CRD that it's unique to that provider, right? I haven't seen yet anything that, a common pattern that all the add-on orchestrators will follow. I don't know if I'm making sense there or not.
Sure, no, it makes sense. I think you defined what the sort of general, if this were to explode into a set of implementations, so not just Helm, then the general functionality that would be common across all is kind of what you laid out. Something like cluster resource sets with orchestration. So basically a controller that sits behind a CRD that has an affinity with clusters running, in CAPI, but with primitive orchestration CRUD as like a first class feature, which is different from CRS. In terms of what would be different between Helm and some other implementation, I think those differences would probably be reflected pretty clearly in the specific CRD specs that those specific implementations would use, if that makes sense. But I want to go back to you made a remark about there's a the chart version correlates with Kubernetes versions. That's actually not exactly right. The version of a chart is simply like any software release. It's just a immutable reference to a chart at a point in time. The part that handles, if I'm on Kubernetes 122, do this, else if I'm on Kubernetes 123, do that. That's baked into the chart itself. That's literally part of the templating of the chart. And it's irrespective of the version of the chart. A chart author might, they might choose to maintain separate versions of charts that deal with separate, versions of Kubernetes, but that would the reason that this capabilities thing in Helm exists as a primitive is to prevent that, because it's a lot of work.
Yeah, I think I misused the word chart. I understood what you meant from the beginning, where you said that functionality was embedded in Helm.
So Fabricio, do you have something?
I want just to add to the set of the idea of set of common capability. I think that in the document we made a first initial effort to lay down what those capability are. One of them is to figure it out, the version of the chart so the version of the add-on according to the Kubernetes version, and there are other listed in the document. So that's the set of capability that we think are necessary. Please comment on that. Then, depending on the add-on manager that you choose, you can get them for free, like we are doing for Helm, or you have to implement them in your proxy and orchestrator. So we go back to the idea that we leverage whatever the community offers as much as possible. So whenever we can avoid to reinvent the wheel, let's do it. And at the extreme, this controller will be really simple, because Helm is fantastic. Is a great tool. Maybe if we use something else, there are some capability missing, and our controller became more complicated. But I think that in terms of general capability and problem that we have to solve, we have a good list. Please chime in, and yeah, that's an interesting part, because if I look at these from a CAPI maintainer, I agree with you. This is a prototype. We are using Helm, but I really would like that this become a pattern, or let me say, a reference implementation that others can use and replicate with other tools. So the community will basically say, oh, you can choose Helm, Flux, or whatever. Those are the proxy stuff that you can use, and choose your flavor.
Kevin, you're pretty active on chat. Do you want to speak up?
Yeah, just a random idea. The one big difference I see here is that you're managing workload on the remote cluster from the management cluster, right? That's kind of different from all the other tools that I've seen. And maybe if it's couched that way, as a way of maintaining remote clusters, then it's not it's in a completely different place than, say, the OLM or Flux or something.
Where you can have those things on workload clusters as well. I think that, I mean, this is the thing about cluster API that's kind of can be mind bending at first, is the management cluster is a Kubernetes cluster. And so all these concepts certainly can travel there. The point is that the scope of this.
You still need an object that says load this over there. And I haven't seen many APIs of that variety. Right, like if you're using Flux to load stuff into your management cluster, it's just loading objects into that local cluster. but this is kind of novel in that you're defining on cluster A stuff that needs to be loaded and maintained in cluster B.
I would say it's not novel in the cluster API sense. That's what cluster API does. Although I do agree in the general sense that it is kind of hard to grok.
Yeah, I'm wondering if it has some overlap with like SIG multi-tenancy or not multi-cluster.
No, I don't think so. This really is a cluster API specific thing. I mean, I would be happy if there are any outcomes that could positively affect the broader ecosystem, but what we have been talking about really is scope to cluster API. We're focused on cluster API customers.
Yeah.
Is that fair to say, Fabrizio?
Yeah, I think that both are true. So one distinction is that we are managing add-ons from the management cluster. This is distinctive of the solution that we're discussing, but it is also true that we are doing this specifically for cluster API. So both of them holds for me.
Mike?
And and then how does that interact with the notion of a joined cluster? Is this workflow still applicable in that kind of case? Or in a joined cluster, would you create the workload first, let the add-ons run, then move the cluster API pieces into that cluster?
Do you mean self-hosted cluster? Yeah, it works.
Right, yeah.
It just works.
So from
the simplest way to think about it is
perspective, then it's like, okay, then you're explicitly not doing what Kevin was just talking about. In that case, you are just running it all on one single cluster.
I think it's easiest to understand in the world of abstractions where there's a management cluster that defines a cluster CRD that has certain labels, and then there's a controller. And then once that affinity is defined and understood during normal reconciliation, then the Helm chart proxy controller has, using cluster API primitives, knows how to get a kube config to the workload cluster for that cluster. It may be the same cluster, but that just confuses things to worry about it at that level. It's better to think in abstractions, like the cluster API cluster is authoritative for how to contact the workload cluster. So the current state of the Helm chart proxy is 100% assumes that we're working in a cluster API ecosystem.
Yeah, I mean, it feels very similar to what the multi-cluster folks were trying to do with KubeFed, and I don't know what the status of KubeFed is anymore, but it feels very much like that.
Maybe not. I think that distinctive value here is we are going to integrate with cluster API. So, and this makes your add-ons basically to pop up in a cluster API according to the cluster API managed the life cycle of the cluster managed by cluster API. So yeah, at the end, we are working with many clusters, but the orchestration tool is really specific. Yeah.
Scott? I think we're just going to run over. Do we have permission to run over? Or do we want to cap it?
It is not a problem. I can stick a little bit longer. I just want to make sure that we give Jonathan room to show everything. If he has to show, I don't know if he has finished it or not. That's the most important things to me. And then eventually we can schedule another meetings in I don't know, in 2 or 3 weeks, because the discussion is really interesting.
Scott, are you willing to hang on for 5 minutes or so?
Yeah, for sure.
Okay, cool. So Jonathan, yeah, there's not, I mean, I don't want to say there's not that much to show because even these little things take a lot of work, but go ahead, Jonathan, you want to?
Yeah. So I think where we were before that. So we can get the values out of the Helm release we installed, and we can see that for here, we resolved the name of the workload cluster using that field. And since we changed this CRD a bit, we can apply it again. And we should see that there is a second revision. And the values have changed. So here we changed limit CPU from 6 to 8.
So this doesn't really show that much value. Imagine that you were running a fleet of 1,000 clusters. Then this is super cool because you could do this with Helm now with a single cluster. I just want to, if anybody's thinking, what's the big deal about this? The big deal is if you had 1,000 clusters, all with that matching label, with a single operational gesture like that, you can update, you can push a change across your fleet.
Yeah,
Yeah,
and
I see
also,
the value of it. It's very much what the multi-cluster folks were doing. They just include not cluster API managed clusters too. Because you might have some bare metal clusters or something that aren't cluster API managed, and you want to manage them exactly the same way.
I think we're at this is just a scoping issue, Kevin. This is scope to cluster API. I mean, at least for this phase of things, if something, if we're able to create value that has general application, then certainly in a follow-up phase, we can discuss how to broaden the scope.
I'm saying if you haven't talked to the multi-cluster folks yet, you probably should. Otherwise, you might be building something that they've already done.
Cool, point taken. Jonathan, you want to progress?
yeah, so also to add on another part where this can have value in cluster API is that we can leverage this, so we can reference a lot of the specific abstractions and resources in cluster API as well. But I guess to wrap up the demo, if we delete this resource, we should see that it's deleted off the workload cluster. But yeah, I guess that's all we have for the prototype for now.
Thank you, Jonathan. I think in order, I will call on Scott. I think, Lubomir, you may have had your hand raised earlier. Maybe you changed your mind. Go ahead, Scott.
Yeah, so this looks awesome. Really awesome. One thing that had been coming up in the chat is, there are other tools that do the multi-cluster as well, right? Already that aren't scoped to CAPI and don't have that integration point into CAPI, be it Cap Controller, Argo, Flux. Has the idea come up of doing this with a much lower level of not actually doing the installation, but trying just to build a shim layer almost of creating an object in the management cluster that would be reconciled? So basically creating a YAML with that templating that you've built with like almost Go templating formats, but create a YAML. So do a cluster resource set almost, but that deploys into the management cluster. So have a selector that creates a Cap Controller app CR, because that can point to the kube config path. All of the other tools that I've seen that are multi-cluster from a single management cluster all accept a kube config secret, which we already have in CAPI. So you cannot need to have the Helm reconciliation and it would make it broader of supporting Flux, Cap, Argo, anything that would be wanted by just adding basically that shim layer of giving where the kube config path is, what the version, whatever someone would want to take out of the cluster spec back into those resources and let the other tools handle the actual reconciliation into clusters.
Yeah, I mean, this all sounds awesome. I would, just based on my experience in this world, I would say the best way to marshal that inertia toward general utility would be to build this thing for cluster API and just make it awesome and then invite folks to make the next iteration that's more general. You know, especially now, this is literally something Jonathan's just doing in his GitHub repo. So there's no danger of us building something that's going to sort of set some IEEE standard for the next 30 years without enough, you know, broad generalization. But I mean, I'm super happy to hear you be able to connect those dots so easily, Scott. That's awesome. Arun?
Yeah, this looks awesome for sure.
Yeah. Thanks for the nice demo, John. I had a question which is more generic on the add-on side. So we know that some clusters are very powerful and strong, and some clusters are very rudimentary. So is there a thought of having some sort of a configurability on a per cluster basis? So if I have a workload cluster, which is a big data cluster, which needs to do a lot, and that requires some more resources or some different kinds of charts as compared to something which is a dev workflow and not doing much.
Yeah, that's interesting. I mean, one thing I could imagine would be if there was some way to, so, you know, in Jonathan's CRD example, there's a CPU limits or resources configuration there. You could maybe imagine computing that at runtime from something that you get from the cluster API resource specs somehow.
Yeah,
Right,
like,
but
Go ahead.
keep going.
so the reason I'm talking about is if Helm solves it, it will solve it in a Helm way. But I want to know if there's a CAPI or a generic method you want to think about for all add-ons in general and solve it that way as compared to the Helm solution alone.
Fabrizio, do you want to take a shot at that? I'm not sure
Yeah.
in terms of largeness or smallness that is actually really a part of the CAPI contract.
No, but I think that, let me say again, we are providing primitives, and with this solution we already have two primitives. One is the label selector. You can define different add-on according to the different clusters. So the second primitive is that you have access to some variable from the cluster, and now with cluster class you can have cluster.topology.variable with a lot of properties of your cluster, and so you have tools to make these to play with these knobs.
Okay, sounds good. Yeah, okay, we can make use of the cluster variables. That's perfect. Thanks, folks.
All right, this was, I think, really lively, way more people than I expected. So I really appreciate Vince reaching out yesterday during the CAPI office hours to encourage us to more broadly advertise this meeting. Glad we recorded. I mean, this is great. I agree, Fabrizio. Let's meet back up here in a couple of weeks. If I see the same folks, that's a really good sign. And Jonathan and I will keep, I think it's time to really lean into the proposal a little bit more. So please, folks, if you really are interested in this, let's hang out on that Google Doc a little bit and get that into, we've kind of, in the race between prototype and spec, the prototype has kind of outrun the spec a little bit. So let's get the spec caught up to reflect some of the learnings from the prototype and from these discussions.
Yeah, and to add on, we're also trying to figure out what the CRD is going to look like. So far, what we have is mostly just to test our controller and see what's possible. So in terms of that, like the UX is still in development. So if you guys have any suggestions on how to do that, especially for the configuring cluster variable stuff, that would be really helpful.
All right. Thanks, folks, for staying on a little longer than scheduled, especially those in time zones like Fabrizio's.
Great demo
Thanks,
again,
Jonathan.
and great discussion.
Yeah, thanks everyone for coming.